Stress analysis is an engineering discipline based on solid mechanics. In engineering world, stress analysis is a primary task for engineers. It looks for not only stress, but also strain, deflection, and other physical quantities that engineers need for design and analysis of a structure. For stress analysis, the first task of an engineer is to convert a real-life engineering problem to a mathematical model. For example, if we want to do analysis to this bike crank, we first need to decide the geometry with appropriate details and what kind of load and boundary conditions this geometry is subject to. The solution of the mathematical model nowadays, with the help from finite element software, is done numerically by computers. This allows engineers to solve much more complicated systems compared to old days. However, software does not do everything automatically. Engineers have the responsibility to make appropriate decisions for simulation. As for finite element method, it's the most widely used numerical method to solve solid mechanical problems. The very basic idea of finite element method is to discretize a domain to many elements, and each element consists of a number of nodes. There are different element types, for example, hexahedral element or tetrahedral element. And finite element method looks for nodal solution on these element nodes instead of continuous solution over the domain. After the problem is solved by finite element, it's engineer's judgment to decide if the result from software is as expected and realistic. An engineer needs to interpret results to check the validity of the design or even find ways to optimize the design. This requires an engineer to have strong knowledge in solid mechanics and familiar with finite element concept. You can see that engineer's role appears in every single step for stress analysis.